Hi, I don't remember my English opening. Hi folks, welcome back to my channel. Today I'm at Statsig interviewing Tim. Tim is Tim, why don't you give a introduction?
Hi, I lead data science at Statsig. I've been with the company from the very start in February of 2021. So prior to this, I was a data scientist at Facebook. So where I spent, I think like total 5 years working on Facebook core app in gaming. And also I worked a little bit in Facebook Reality Labs. So doing some of the more cutting edge metaverse style projects. So I tell people that I've worked on products that have had as large as 1 billion users and as small as just like 10,000 users.
Which one is the 10,000 users?
That would be like the Facebook Reality Labs, yeah.
We are having that many users today. What is the 1 billion?
So that would be like on Facebook gaming. It's just like you had that many eyeballs on gaming content. It was our opportunity to try to capture that and drive engagement.
How is working at the startup?
Yeah, it's been a lot of fun. It's been pretty intense. I think I've been able to learn a bunch of new skills that I would have never had the opportunity before. So being the only data person on the team.
Wait, the only?
At the beginning, I was the only data person on the team. Is like I had to be more than a data sicentist. I had to be also a data engineer. I also had to be a data architect and design that. I also had to be thinking. There was no one else thinking at the time about things like marketing or our business positioning or our strategy. Like even those sort of things, I was able to contribute to at the early start.
How many data people do you have today?
We have 3 data scientists, and we have a lot of engineers working on the data infrastructure side. Yeah.
How do you define engineers working on data infrastructure versus data engineer?
Yeah, it's actually a blurry line.
Yeah.
I don't think there's actually a really clear definition, and I think there's a lot of shared responsibilities between the two.
But okay, so early on you were basically a jack of all trades, but mainly as a data scientist, what is your unique value or unique contribution that no one else can replace?
At Statsig?
At Statsig,
At Statsig, yeah. I think the way I view is that because we're selling an analytics tool, we not only are there to engage with other data scientists, because other data scientists want to be able to speak with somebody who understands data science. And it's just partly they have to believe that we've set up the analytics and the computations correctly. Yeah. And so we're the ones that, we do that, and we're also the ones that are able to communicate that. So that's like the first thing. The second thing is like we also represent the viewpoint of the customers when building our tool. There's 2 perspectives. One is like what would a data scientist want to see in the product, but also data scientists are a little bit like almost guardians of like data at their companies and how people use data. And so they have to be able to trust that we are putting a tool in the hands of PMs and engineers, and data scientists want to make sure we're doing it faithfully in a way that doesn't cause them more work. Because there's ways to misinterpret data that could actually cause like people to have wrong insights. And in that point, like data scientists are now struggling to actually squash problems that we've created instead of us solving problems for them.
I think there are 2 main follow-up questions from this. One, Statsig's mission or Statsig's differentiator with other A/B testing companies like Splitwise or whatever, optimize with your other competitors is you want to make A/B testing easier, thus less complicated or less academically, right? I feel like that creates some tension between like giving this to 2 engineers and they can just run it versus a data scientists want to have a rigorous process and a rigorous thinking after like with the A/B testing. Then how do you balance that? And the second question is in order to convince other data scientists, your customers, data scientists, that we are providing the right tool, you basically have to know more than them, right? Do you feel that to be a necessity?
But I think I'll start with like your first question over like how do we balance making experimentation accessible, but also being like rigorous.
Yeah.
And that is the biggest challenge we have as a data science team. Actually, I think that's the biggest challenge we have as a company in general, because our tool is fairly sophisticated from a stats and analytics perspective, and yet we're trying to put this powerful tool in the hands of people who may not fully understand statistics or may not know the definition of a p-value. I think a lot of what we're building is fueled by the fact that we've seen this work at Facebook or Meta, that like you can put a powerful statistical tool in the hands of people who aren't data scientists and have it really power product development. And so we've tried to capture some of that nicety, but also adding our own flavor on top of that. It is tricky, and it is something that like we actively think about. What we try very hard to is, our principle is that we will give you a lot of flexibility, but we will try to guide you through UI and design to best practices. So things like making sure that when you are deciding how long to run an experiment for, that there's a power calculator that's readily accessible. Things like if you are going to make an early decision, we actually let you know that like, hey, it's possible this experiment is not fully powered yet. Just little nudges like that into the UI and design that sort of like guide people where you may not fully understand like the peaking problem and like the nuances of it, but the fact that our UI is sort of like pushing you to run this experiment a little longer than you may be, or that just to let you know a warning that you are making an early decision. These are just kind of the things that we've tried to build in.
From your experience, what kind of knowledge or understanding does it take for someone to use the tool correctly without the UI nudges? Like not knowing the definition of a p-value or not understanding the true implications of p-value. Is it okay to?
Yeah, I think this is we discuss this heavily a lot because like ultimately we are showing frequentist results that have p-values and confidence intervals, and we know what those mean to statisticians. And that might not necessarily be the takeaway that someone who doesn't understand type 1 and type 2 errors will take away. But what we do want to let people know is, like, for example, like subtle indicators like making a result green signify that this is actually the result you are looking for. That this is like, we all know this means it's a low p-value underneath your 95% significance threshold. And while an experimentalist may not actually know that full definition, seeing a green result should give you some confidence that that is actually what you're trying to look for when you're running this. We also do things like making sure that we encourage folks to list out their key metrics up front. That's experimental best practice.
How much is the information lost?
Yeah, so we do this, the way our UI is designed, and probably this is best for a lot of like really technical products, is that we actually show you a very simplified version of your data where it's very distilled down, and there's like very visually you can sort of like instantly get some very key takeaways. But what we hope, and this is especially true in experimentation, it's a lot of like peeling an onion, where like whenever you see initial results, at least data people will have like follow-up questions immediately.
Yeah.
And you'll want to drill in on those. And so we actually provide in the UI like very easy ways to go deeper and deeper into more complex things, into more complex statistics. So we haven't dumbed down our product. Like we've simplified the initial version, but if you wanted all the complex stats and the drill down, such as being able to see time series or filters by cohorts, like that's all available. In there and readily accessible.
That is actually a great point, because I feel like at least at Facebook or other companies I work at, when people see experimental results, data scientists, back to a roadmap post as well, data scientists usually have hypotheses. They want to understand why this result happened, right? Versus a lot of PMs and engineers, they are looking for specific results. They're looking for the green. If they got the green, then good to go. If they don't get the green, they want to, what else can I try to make it green? And sometimes they don't have hypothesis behind it.
Yeah, this is one area that we really want to train our customers. It's like, you don't want to just look for the green. You want to be able. I call it telling a complete story. That like that whatever results you see should be consistent with the change that you made, and it should be somewhat expected. If you have something very unexpected, you should question that result. And so we try to make sure that that's why we ask for folks to put their hypothesis down, what they expect to see, and quote some metrics that they expect to move. Things should be somewhat consistent. You shouldn't just look for green things just to make that decision, yeah.
I also feel like when people have hypotheses, they usually overestimate how often they are right. Like
Absolutely.
which is at 1/3, but in the online control experiment, like 1/10 of the hypotheses are as expected. Right, most of the changes they either are insignificant or even like proven to be negative. So people would have frustration when they don't see the green. And sometimes the frustration can be a question about the tools. Like, I was right and your tool is not showing me green, so your tool must be wrong.
Yeah, we have this happen all the time. I find that experimentation is like super humbling, not only in like the number of ideas that you could have that work, but also in the magnitude.
Yeah.
Like very oftentimes, like if somebody's never done experimentation, they'll say like, oh yeah, this change is so obvious, this is gonna be so good, it's gonna be plus 10% to revenue. And then they run it and it may still be good, but it's like plus 1%. And it's just like, you have to, I think like everyone who does experimentation sort of like knows how to calibrate downward. It never calibrates upward. But we also find that some companies also just have a higher batting average. So usually small companies that are working on unoptimized products, usually there's a lot more wins around. But whereas if you're at a big company like Facebook level, the number of good ideas that are out there is far fewer. So yeah, so it's a lot harder to find those wins. But yeah, it's something we have to temper expectations of our customers. That like, hey, this is like the fact you are seeing a negative result or a neutral result is not a bad thing. Like you actually now are able to measure your impact. It's up to you what you do with it.
I feel like this would be way easier if they like your customer have seen like work at Facebook, for example, like and seen this work, and it would be way harder if they never ran experiments before or like correct experiments before.
Yeah.
Like the latter problem, is it even solvable? Like,
yeah, you're 100% correct. I think our biggest challenge is getting people to realize the value of experimentation. I think if people have worked at a company like Facebook or Google or Microsoft, they sort of understand the value of experimentation. But if you've never been exposed to that and you read things online, I think it's harder to convince you that this is a good thing. Yeah, but that's our challenge, is like to show people how it's done at big companies, medium-sized and small companies, and what sort of learnings and how people are using it today, and how that's driving product development.
Have you had examples of people not believing it at first, or very skeptical at first, and then over time start to trust it more?
We're starting to chip away at that. I don't think we've had somebody who's completely skeptical use our product and be convinced the other way. But we've had people who have been, listen, we want to try Statsig for just rolling out features. And just the fact they're seeing measurement and data, now they're realizing, oh, we can actually start to make decisions on this that they may not have in the past. And so I think just by, the way I view it is like we're just shining a flashlight on like what your features are actually doing. It's up to you to take a look. It's up to you to interpret it, and it's up to you to make decisions. But I think just showing people, just shining light on this data and results has been pretty powerful so far in getting people to realize the value.
Yeah. It is a necessary first step, but like unleashing the power or the full potential, right? I feel like there are several steps. For example, you need to just measure which one is positive and which one is negative. But then you need to build hypothesis and understand a product and guide it to a better direction. That's the forward thinking part comes in. I think we already transitioned into the second question, so let's just go there. How do you feel I guess talent density or whatever, like in order to do, especially step 2, right? like realizing this, realizing the power of experiments. I feel like this power is step one, and unleashing the power by having hypotheses and having the experiments, not only to tell you which one is positive, but also to help you learn your customer better or learn your products better. I feel like that takes talents, right? How do you feel?
Yeah, I think the experimentation journey is actually like fairly long. Like when you first start using it, you can operate at one level, but you have to become sort of like practiced, and hopefully like having a reliable tool supports that. But there's definitely many layers you can get to in experimentation, to the point where you're actually comfortable just trying random ideas, and being able to just build it quickly and test quickly. I think that to me is where what we saw happen at Facebook, and what we think companies can get to eventually. But I think you're right that people have to take small steps in order to get to that point.
Yeah, my question is about, do you see the second step being done at companies or other than these big tech companies? Like having hypotheses around the experiments, interpreting the results to understand the product and the people, the customers, instead of just, this is positive, that is negative, let's move on.
Yeah, I think, we guide people that there. We actually tell people that you should be focusing on metrics that matter to you. You should be focusing on the user experience, and the metrics that you see go positive, negative, or neutral should be consistent with what you think the user is experiencing. I think different companies are at different stages. I find that if there is a data scientist on the other side, they can actually use Statsig to guide their teams to how to interpret this, and I think that's usually a faster process. But then we also have found that like purely engineering teams are able to sort of view metrics with a degree of skepticism, and so therefore start actually being able to interpret it properly.
Oh, nice.
But that's I think it's easier if you have somebody to guide that, and that's partly the role of a data scientist.
All right. Then my question is about the distribution of data scientists at different stage of companies, right? You said you have a spectrum mixture of different companies. So very early, I guess Series A, Series B, and then pre-IPO and big IPO companies. I don't know if that's the right cut of stages, but the distribution of data scientists.
Yeah. I sort of link this to what I call data maturity, and it's very different. It's there's not really a set formula that like once you hit 20 engineers, you must have your first data scientist. We've seen some companies bring on a data person very early on, and we've seen other companies like not have any data people till they get to be like fairly large. There's not really a set formula. I think for me, and we have to work with all companies all across the spectrum. I think and so the way I see like sort of the data maturity going is that usually you'll get your first data person that will actually start helping the real value of a data scientist to me is like helping the rest of your team up level their analytics ability, helping them understand how to interpret data. Like the data scientists themselves can produce insights, but I think the real power is actually educating your team how to use data properly.
Data maturity, this at the different stages of data maturity, do they really first hire a data engineer or a data analytics?
I think so. If you go by the book, I've seen like best practices that usually you bring in a data engineer first, so they can sort of at least lay down the groundwork that like here's a few data sets, and engineers and PMs can sort of like do some basic queries on there in order to be able to get some value out, and so usually a data scientist comes after. I have seen times where your first data scientist is hired before a data engineer, but their work that they start doing at the beginning is data engineering work.
Yeah, I heard this happen a lot at pharmaceutical companies. Actually, the executives want to do deep learning. They want to do AI, so they hire a lot of AI scientists, and they end up doing data engineering work.
Yeah, I think it's one of these things where if you don't have that function at your company, it's hard to, that first person you hire is actually hard to know what you're looking for. It's actually, how does a person interview someone in another field and know that they're going to be a fit for the company? It's like, it's a little bit tricky.
Yeah.
Yeah.
Then what is your advice for data scientists who want to try working at a startup? Because it's very easy for engineers to jump from a big tech to startups, but perceived as very hard for data scientists to do so. Like for example, data scientists at big companies, they are used to this nice infrastructure, clean data, and they start to.
Yeah, I think it's so. I would have two pieces of advice. So one is just have a very much a startup mentality, where you are prepared to roll up your sleeves. And I tell people like get dirty with the data. Like there is no data task that is beneath you if you're at a startup. So like even just cleaning data, removing nulls, like just the basic grunt work. Like there's no one else to do it. You have to do it. That is like the first thing is just like that's the startup mentality. The second one is just, and maybe it's similar, but be prepared to like learn new skills. Be willing to learn new skills. Be willing to try things that are outside your comfort zone. And so, like for example, one of the things we had to do was learn how to set up how to set up Spark for our compute, and that is not something which I would have ever thought I would know how to do.
Funny fact, back at Amazon, I spent a week setting up Spark to query data from other orgs.
Okay, nice.
But like I know the task would take a data engineer at most half a day.
Yeah.
Yeah.
Yeah, but it's one of these things where like and I fully know that somebody else could have done this job faster, but there's nobody else around.
Yeah.
You are the person. So like you have no choice but to roll up your sleeves and just find a way to do it and learn. And find the quickest way to do it. Like you know you haven't done it well, but it's good enough to move forward.
So I guess it doesn't hurt to be more full stack, especially if like for startup you have to be full stack, kind of. Yeah.
I think like so when I joined Statsig, I was not full stack, but I think my recommendation is just a willingness to learn, or just a can-do attitude, like to know like
happiness.
Yeah. That's exactly it. Yeah. So just like find a way to do it, and even if it's outside your comfort zone.
Yeah. Because you deal with a lot of startups who needs data scientists, basically, right? At least they need a tool to run experiments. Do you think it's going to be a viable path or like growing path for data scientists or to join startup companies? Or do they feel like your tool can just satisfy most of the demand?
I think it depends what it is that your company is looking for. But I find the way I phrase what Statsig does is we actually up-level your data scientists. When I was at Facebook, and maybe you had the same experience, I had interviewed like hundreds of other data scientists, and I would always just, as a warm-up question, just ask them like, hey, so how's your current company and why are you looking for a job? And more than half the times, they would tell me like, hey, I'm like the only data scientist at a small startup and all I'm doing is crunching confidence intervals.
Yeah.
And it sucks. And I've been there. I know like it's super tedious. It's one of those things where like if you mess up one small part of the calculation, you'll get the opposite insight. And so you have to like triple check, quadruple check these things. It's like, it's not fun, and it doesn't feel like a company's getting their full value of their data scientists if they have them just crunching confidence intervals. So data scientists don't want to do that job, and the company probably doesn't want their data scientists doing that job. So I think our tool can come in and sort of take that very elementary level of analytics burden off of the data scientist. So now the data scientist is not crunching results. They're now focusing on more important problems such as designing the experiment, interpreting the experiment, looking for follow-ups, like diving deep into the data and seeing what else other insights there are. I think like that's where a data scientist starts bringing a lot more value to their company than just crunching A/B test results.
So I guess by making experiments easier and easier to run, right? And unleashing the power of data scientists, we can actually have data scientists contributing more to these companies, and hopefully we can have more data scientists working at these companies as well.
Yeah.
All right.
That's it.
Okay. Thank you, Tim.
Awesome.
Do you have any other things you want to add?
No, thank you very much.
Also heard Statsig is hiring data scientists.
Yes.
What kind of data scientists are you hiring?
We're hiring data scientists and data engineers, and I think as long as we continue to succeed, we will continue to be hiring, because even if we don't have actually job openings. But the data scientists we're looking for, there's sort of like two skills, and one is like being able to work with customers directly. So communication skills, being able to translate statistics or complicated experimental concepts in easy plain English is a pretty important one. The second one is more on the technical side, so like being able to put ideas and data science concepts into code. So being able to write in SQL, being able to write in Spark. And so that might be, I would call a little bit more of like a statistical engineer or an analytics engineer. Yeah, but those are the sort of two skills, and they're kind of on the opposite side of the spectrum.
Applied statistics.
Maybe applied statistics, yeah. But essentially, like, we need people who can work in the code base and ship production code.
Nice.
Yeah.
Okay. What about data engineers?
Data engineering is something similar.
Do you have any?
We don't have any. We're looking. Yeah, I think like data modeling is something we need to bring in. So you asked what the difference is between an engineer that does works with data and a data engineer, and I mentioned there's a lot of overlap. I think one thing that doesn't overlap well is actually data modeling, and I think like data engineers who are really good at data modeling is something we're looking for.
All right. Okay. Thank you. If you are interested, you can find Tim on LinkedIn.
Yeah, absolutely. Please.
All right. Thank you.
Thank you.
Bye.